Again, a very warm welcome to everyone that has joined our virtual panel session today. I have great speakers here that we will shortly hear from. But before we get started, I would like to introduce to the topic. And our topic today is demystifying the 5G standardization process and what can data tell us. And many of you know we are a data company, so I wanted to start with showing you some data that we have on the 3GPP, that organization that is responsible for the telecommunications standardization process. And I think many people often underestimate of what a huge open innovation project or group the 3GPP is, with thousands of companies, 10,000 of engineers participating every year. And when we look at the data, you see that over time, and that is per year submissions of technical contributions. We will discuss in a minute what a technical contribution really is. But if you look at this over time, we see that since 2015, the number of contributions has been increasing in waves, and we will also discuss why that is. But what is important to understand that we are started at around 50,000 submissions of these contributions, and over the past 3, 4, 5 years, we have on average 100,000 contributions. Not all of these are technical documents always, but it shows you the magnitude of how much technical input we see at the 3GPP every year. If you look at this and we want to categorize contributions by technology generation, we do see that a big project that has increased the number of contributions by far is the 5G, the 5th generation development standard, which started in early 2016, and you see the sharp increase on contributions. Actually, if you would summarize together, 5G alone and contributions we can associate to 5G are more in numbers than 3G and 4G together. So again, also that shows that by each generation, technology generation, the number of contributions and the complexity, technical complexity, has been increasing. The 3GPP is organized in different groups, and also there we will hear from our experts today what those groups mean. But if you look at those groups, also there the groups have different, of course, output. Round 1, round 2, the physical layer technology groups have by far the largest. Round 1 with 150,000 contributions, followed also by groups like round 4 and other groups that we will see here. Another fact that does not relate to the 3GPP directly, but it relates to the world of patents and patent filings and standards development, is that these documents, these technical input of what later becomes a standard, are often also prior art to patents. In fact, actually, if you look at declared patents, those that are potentially essential, the majority of those cite as prior art standardization documents, not other patents. And if you look at the standardization documents that are cited, most of these are not the final standards. Most of those are technical contribution documents. And there's a nice paper here that looked at this, an economic paper that looked at this in more detail if you're interested to learn more. Also, there's another research that was done that basically looked at the patent examiner rate and the number of approvals of patents that have been provided to the patent office. And they compared the European Patent Office access to standards contribution data. And what it shows that drastically, if you compare that, for example, with the USPTO, where there was not such access to the data, the patent quality has increased. So we do see, yes, standardization documents and contribution documents are prior art and are technical input that are also potentially patentable. That paper also looks at the meetings and shows that those inventors that go to the meetings often have submitted priority applications or provisionals in the US just before those meetings, which is interesting. And that author basically shows, that the link between inventors and people that go to standards meetings. And also at IPlytics, we have looked at the attendance of people and compared the names of the people who attended the 3GPP with names listed on declared potentially essential patents. And we did find on average that in 72% of the cases, at least one inventor has also been at one of those meetings where the standard was discussed. That is different by companies. So some companies, have a more overlap between people that go to meetings, but that is a statistic that we created at IPlytics. But that is enough data. I want to hear now from our experts, and I'm super happy to have here with me today for people that are experts and long-year members of the 3GPP. And to get started, I would love to hear from you, first of all, and get an introduction of who you are and your experience. And I would say ladies first. Diana, if you want to get started, please go ahead.
All right, thank you, Tim, and thanks for having us here in this what I hope is going to be a very interesting panel. So I'm Diana. I work at Interdigital. I've been leading the 3GPP standards and innovation team here for a few years now. I've been developing 3GPP technology over 3G, 4G, and 5G over the last 20 years. And in addition to this, I've also been attending 3GPP for 15 years now. And during this time, I've also had the opportunity to be vice chair and continuing to be session chair, meaning leading a number of the sessions in the working group too. And I'm still chairing some sessions for 5G Advanced. So I hope I can use some of my experience to answer some of your questions today.
I'm sure you will, Diana. Great experience. Let's go around the horn. Janne, could you please introduce yourself next?
Yes, so my name is Janne Peisa, and I am currently responsible for Ericsson standardization activities in forums like 3GPP and ORAN and a number of other forums as well. And I have a long history of doing different generations for mobile networks, starting with 3G. I have been involved in research. I have been involved in standardization, where I was leading the Ericsson Run 2 team for a while. And then I was, after that, leading the whole Ericsson Run team, being the overall coordinator and head of delegation in that role. And have also been leading a number of research projects looking into developing the 4G and 5G technology. And currently I'm also responsible for coordinating the 6G initiatives within the company.
Great, thank you, Janne. Another very experienced participant here. Thomas, you're next.
Hi, Tim. Hi, everyone. And also thanks for inviting me for this webinar. So I'm Tuomas Saukkonen. I come from Nokia Technologies, where I'm heading the Nokia cellular standards patent portfolio. And I also have over 20 years of experience with 3GPP technology. So first of all, as a researcher, starting with 3G, and then moving to IPR department at the later point. So basically, not representing Nokia here as a standard delegate or standard expert, but more kind of bringing the patent side into the picture.
Very good, Thomas. Thanks for your introduction. And last but not least, Lorenzo.
Hello, thanks also from my side for inviting me, organizing this webinar. My name is Lorenzo. I've been with Qualcomm for over 20 years. For the vast majority of this time, I've been involved in standardization projects. I've been responsible for a 3GPP standards team for about 10 years and throughout most of the lifetime of 5G and its creation. And in the last couple of years, I also joined our licensing business unit, being responsible for all of the technology projects related to cellular and cellular-based IPR in our licensing business.
Great, thank you, Lorenzo. I think we do have a great experienced panel here with different focuses, which is always exciting. But to get started, I know that our audience, not all are as experienced as you are. So it would be great to have a high-level introduction into what the 3GPP is, what the 3GPP does. Diana, if you would go first and give us a high-level understanding of, if you would explain it to your grandmother, what is 3GPP, what is going on there, how can we imagine, 5G came to life?
All right, well, thanks, Tim. It's a good question. I don't know if all grandmas will understand it, but I'll attempt. So 3GPP, I think you mentioned it at the beginning, but it's a global standardization organization that develops the future of cellular technologies, right? We have a huge track record of developing 3G, 4G, and 5G. But essentially what it does at the end is that it produces what we call technical specifications. And it's basically a description of how the system works end to end. Basically, how do devices communicate to each other? That's the end result of what we want to achieve in 3GPP. It's a member-driven, consensus-based type of organization. So that basically means that representatives from different companies come together in what we call 3GPP meetings, and they discuss and need to agree, all of them together, on what is the best way to design the standards. And just to give you an idea, I think you mentioned some numbers at the beginning, but for every meeting, we have about 200 member companies that attend. It's a wide variety of companies from all over the world. They represent device vendors, network vendors, chipset vendors, operators, research companies. You have millions and millions of research companies that attend and participate to these meetings, and they send representatives. So you have about 1,500, 1,600 representatives in every meetings that come together to discuss how the future of the technology is going to develop. Now, you mentioned this different working groups. I wanted to clarify that it's not just one 3GPP meeting where all these thousands of delegates get together. It's a complex system. And because it's an end-to-end system, it means that, you know, we have areas from the radio access side that need to be discussed. We have areas in system architecture and services that need to be discussed. We have the core network that needs to be discussed. And therefore, to enable this different group of experts to get together, 3GPP has created working groups. So these are groups that do the technical work. There's about 15 of them that basically different members of this 1,500 representatives attend. And companies meet 6 to 12 times a year in different parts of the world to discuss different parts of the technology. And we also have 3 groups, which we call the plenary groups, or the technical specification groups that oversee the work of all these working groups. They're like the project managers of all the working groups. They make the decisions. They discuss what's important for the industry. What are we going to specify? How long are we going to take to specify all of this? And it's typically 15 to 18 months of work that takes place for every single release. So all of these groups end up meeting in parallel. You have hundreds of people in each of these groups. And then they're split. Some of these groups like RAN 1, RAN 2, SA2, RAN 4, because it's such a big group, and there's so much work, they're split in additional subgroups. So there's even more parallelism going on in the work of all the 3GPP groups, right? So then I guess some of the key questions are, well, how do companies participate to the meetings, and how are decisions made, right? If you envision thousands and thousands of contributions and people, how does the work get done? So I think, first of all, like I said, it's a member-driven organization, which means it relies on the work of all the companies to advance and move forward. So how do companies contribute? Well, of course, every company has done their research, they have their expertise and interests. And what they do before every meeting, they prepare technical documents. And these technical documents are contributions that you provided, statistics at the very beginning. And it is by these technical documents that they bring the best ideas or their best technology solutions for 3GPP and to advance the ecosystem. So they bring their ideas. They typically submit it like maybe a week before the meeting, because other companies need to have the time to read, review, understand what each company is going to propose and be prepared to start discussing them in the meeting. Right, and as you saw, or as you showed, there's thousands of documents submitted every meeting. And in some of the working groups like RAN 1 and RAN 2, you have 2,000 documents every meeting submitted. So then how are discussions organized and how are decisions made? Well, typically you will have, the discussions will take place live in the meeting. There is typically chairs, vice chairs, session chairs that have the responsibility to lead these meetings, and they have the responsibility to organize, prioritize, set the agenda, select a few contributions for discussions, and then after they select the contributions, then member companies can start the discussions. And this chairperson is typically elected by the member organizations, and they're there to act fairly and impartially and act for the good of 3GPP, right? And their main goal is to drive consensus, to make companies discuss, provide their technical arguments, but at the end, they need to agree together on what's best for the system. So this is where the complexity starts, because it's a living consensus approach, and it's imagine trying to have 100 people agree with each other. So that's where the complexity starts. But of course, at the end, it's at everybody's interest to progress and agree. So companies collaborate, they compromise, and at the end agree on what's best for the industry. I think, Tim, maybe one interesting point too is that the agreements or the way decisions are made, they're taken step by step. There's no such a thing as a company brings a contribution that shows the whole system from end to end, and that's what gets agreed. What happens is every meeting, a company brings their ideas, and then a discussion takes place between all the ideas, an agreement is made, and that's a high-level agreement. Then the next meeting, companies go back home, they think about what was agreed, and then they reevaluate what they will bring in the next meeting, because what they might have wanted in the first place didn't happen, but it doesn't mean they cannot keep on contributing with new ideas. So that's how the system is built, is like piece by piece. So at the end, what happens, the technical specifications contain a collection of everybody's ideas. So it's pieces of everybody's ideas that are put together. I think I was trying to think of a good analogy of how this works, and maybe it's not the best analogy, but if you think of building a house, you take 100 people and you say, now build a house, agree together on every piece of the house. What will happen is you will have a group that will decide, oh, how do we want this house to look? What is the use of this house? Who's going to use it? How big? How long do we have to construct it? And then you will have the people that will start doing the work. You will have to first agree on the foundation, right? Some people will say, oh, we have to pour concrete. Some want to put rocks. I don't know how to build houses, but and then once they agree, the next step will be, okay, let's talk about the structure of the house. So some companies will come and say, oh, we think a brick is best. Another company will say wood. So based on every decision that's taken place, then the next step of the house building will take place. So then there'll be the windows, then you'll have a group that's going to talk about the kitchen. And then if you're going to look at the final product of the house, it's going to be pieces of different companies' ideas that were put together. So no house will look like one company's vision at the beginning. At the end, it will be a different house, but it will be a completed house that contains the best pieces. And it's to everybody's interest that this house is completed and built, because if you don't build the house, then nobody has anything to show for. So this is why the process is quite interesting, and it's also quite complex. But it's all based on consensus, so it's very important that you have consensus builders in these meetings that participate as experts. I don't know if that answered your question for grandma, but
I'm not sure about my grandma, but I have a great picture in my mind now. Maybe also to add to your analogy, of course, in order to everyone speak the same language, people have to be in the same house, right? And that is exactly what the standardization is for, right? The different devices and use cases and all of that need to speak the same language to communicate, because they come from different vendors. And I think that's what makes it so exciting. Everyone has the incentive to build really something that makes, devices work together. There's already one quick question, which I think is a good fit here, which is about, if you think about the hierarchical structures of the 3GPP or the standardization process, how is that similar or different from other organizations like the ITUT, ISO, IAC, or are they following similar concepts? If you know, should you know?
I'm not fully aware with all the other organizations, but at least, I mean, maybe I forgot to mention too, there are organizations that decisions are made based on votings, right?
Yeah.
The Wi-Fi IEEE organizations, they base their technology and standards via voting on proposals and contributions.
Yeah.
But 3GPP is not like that. We do not vote on contributions. We have to build consensus.
Yeah. Yeah, I think that is particularly interesting. And I think if you think about the open innovation concept, which I, as an economist, learned, this funnel of ideas, and then the solution at the end is a combination of all that. I think it truly sounds like that is that. I think what I also like about this 3GPP, it's very transparent. You can really look at any meeting. You can read any contribution if you would like. It's all online. It's all available. And of course, I know that because we at IPlytics do that. Not that I read anything, but we allow a system to read it. But there are, of course, or to put it that way, it's still challenging to understand that data. And when we talk about contributions, and maybe that's my next question here addressed to Janne. If we talk about contributions, there are differences, right? There are change requests, work items. Certain contributions get approved, accepted. There are different groups, as we just learned, but also there are releases, and there are these technology generations. Can you give us some insights? If I would look at contributions, what will I see, and how can I understand what a contribution really is? And how are they comparable? Are they apples and oranges, or are they all the same? Can you give us some insights on that?
Yes, I'm very happy to try to give a short summary of what kind of contributions 3GPP has and how 3GPP work is organized. So fundamentally, I think you can classify the 3GPP contributions to very many different categories, but they are, on one hand, they are administrative. We have documents like agenda for a meeting, minutes of the meeting, liaison statements that are used to communicate between different working groups and different organizations. We have summaries of discussions, summaries of email discussions, and so on. So kind of documents that are providing the necessary housekeeping for making it an efficient organization. And then we have all the other, then we have actual technical contributions that are providing some kind of technical input to the meeting. And those can also be grouped in different groups. But one very fundamental type of a technical contribution is a request to make a change into actual technical specification, so-called change request. So request to do a change. That is then a formal document that is asking for some kind of a change of language, change of additional new feature, any kind of a change that goes in specification. And they are kind of the tool which 3GPP uses to actually build and update their specifications. They are important, but then also what is important are technical documents that are not formal change requests. Technical documents that are proposing new ideas, that are trying to explain on what is the rationale for doing a change, that are trying to highlight a problem. And I think those would be classified broadly as discussion documents. They are documents that are, in one way or other, expecting to raise a discussion in 3GPP, bringing an attention on technical matter, providing technical justification for a change that you are providing. And they both are important in the sense that they both are needed for 3GPP to actually maintain and create their specifications. And maybe these are the most important contributions that we have. We have the discussion documents and the change requests that are technical documents. Then you also touch upon the how 3GPP organize the work. And the idea in 3GPP is to create fairly large packages of new feature, kind of put together everything that can be specified in a time period of 1 to 2 years, very typically 1.5 years. And then this contents of this package, that's called a 3GPP release. And in one release, you typically you add new functionality, you enhance the existing functionality, and you provide an evolution part for your system by making sure that the latest technical developments are possible to deploy in your mobile networks. The releases can be really, really dramatic. They can introduce a completely new system. So we had release 8 that was introducing 4G and release 15 that was introducing 5G, or they can be a bit smaller, like release 9 that did minor updates into 4G, or release 16 that brought in some new functionality for 5G, but did not really rework it completely. And the contents of the release, it consists of number of agreed building blocks, number of agreed features to introduce, and these are then the work items. It's kind of it's an agreed statement of work. This is the function that we are going to introduce. We have this justification for it. For example, we are providing carrier aggregation that allows you to aggregate neighboring carriers to make it possible for operators to better use their spectrum. And it provides an objective. These are the goals of the work. We are aiming to do aggregation of 2 carriers at this point of time. We do not look into 4 carriers. We don't look at very random combination of bands. So it's kind of an agreement on what is the scope of a particular piece of work. It's a work item, and this work item is then packaged together with other work items to create a release that is then coming up in every 1 to 2 years. It's also worth noting that even though the releases, they only happen every 1.5 years roughly, the 3GPP specifications, they are updated much more frequently. So basically 4 times a year, there is a new version of the 3GPP specification that contains a number of error corrections. It may contain small additional features, but primarily it contains error corrections and allows the system to really address any known issues at a pace that is much faster than this 1.5 year cycle of a new release.
Great. I think what my main takeaway is, it's all very dynamic. I think also that is a good takeaway here. It's not that you finish 5G and then you go back and work is done. You keep improving it with, as you said, release 15 was the release where 5G was introduced, but there are more release coming after. I don't know what release we are at, but I think like 18 even, or even beyond. You see that, you know, the 5G standard is not 5G than it was when introduced. So it has been improving. New contributions were submitted. And I think that is also one thing that is important to understand, that if a standard is not, at least in cellular technology, the standard is not finished and closed. Of course, you have these what you call freeze, right? And then those release freezes. So I guess if I think about products, certain products may not always have the latest release implemented, right? That may also be true.
Yeah, I guess it's safe to say that there is no way you can implement a release at the moment it is released. So there is a certain gap on having the specification available and having the product ready. But that gap can vary quite a lot depending on feature. So 3GPP is a fairly productive organization. It does many new features, and some of the features are almost immediately commercialized. In best cases, there is a gap of half a month to a year from having the specification available, having the product out in the field. In a worst case, there is no market demand for a feature, and then it can take a long time, or it may never get implemented. So there is kind of even though many 3GPP features are implemented, there is always this interplay of what has been specified and what actually is a commercial demand for a feature that will only be found out once the specifications are available and the companies are able to make their investment decisions based on the estimated market demand at that point of time.
Yeah, and that's also an interesting takeaway. There's also a demand market, as I would call it as an economist. Put differently, you're not pushing the standard on companies to use it, but they can also decide when to implement and how and in which products it makes sense. So I think that is also something really important to understand. And I know, and Diana said that in the beginning, that the purpose of standards development is coming together and solving a technology, having something that makes devices connect and speak to each other. But and it's not about, of course, filing patents and making money on FEPs. I think that is also something we want to demystify today. But of course, there is a relation to patented technology, and I'm happy to have Thomas here that can speak about that a bit, because I'm curious to understand how companies organize that. If I would imagine, you know, Nokia is sending their engineers to the meetings and there is patented technology involved, how do you make sure that it's secured beforehand? Are these standards development people really communicating a lot with the patent departments or the patent board? Is that very strategic, or is that more natural? It comes out of R&D. If you could walk us through a little bit there, you know, how we can imagine that, and, you know, also demystifying maybe some of the rumors that are going on around SEPs pushed into a standard.
Okay, Tim, great to talk about this important matters, and let's say also taking first about this grandma view into the picture. So how to really introduce to the process what comes to the patents and the patenting for the layman person. So obviously, when if you wish to get the patent protection for your invention, which is going to be published in a form of a contribution. So always the patent filing needs to happen before the publication date of the contribution. So therefore, first of all, it's a very common practice in the industry that we file patent applications for inventions which will be disclosed in a form of contributions to the public. So meaning to the 3GPP, which is an open and public standardization body. So where everyone can have access to the information. So basically, in practice, when companies find the contributions that they involve an invention that is worth of protecting with IPR, so it gets filed. So like Jan discussed about different types of contributions. So there are technical contributions in nature. There are contributions which are related to agenda or meeting minutes. Also, there can be also contributions that are resubmitted. So you really need to look at that the contribution that is related to your invention is something that is not yet published, and it truly covers a technical feature, technical implementation that is new and inventive. So that is the starting point for starting to consider filing a patent application for the particular invention. So maybe then highlight a bit more how the process actually works. So when the inventors who can be the standard delegate, like you nicely showed in one of your slides, Tim, about the percentage of in different companies be acting as an inventor for the standardization of patents. So there can be different types of inventors. So not only the people who attend the meetings, but also having the researchers doing the research work and coming up with inventions. And also we have, let's say, product R&D folks who are actually implementing the products and also are solving the problems that we are facing when developing the 3GPP standard. So I describe all of these. So whether you are delegate, a researcher not attending the meetings, or you are a product engineer working on the 3GPP standard implementation, so they are collectively called as inventors. So when the inventor is first of all, you need to detect a problem to be solved. And when you find a solution for it, you can file an invention report, which is describing the problem and the solution, among other things. So that invention report is then submitted to IPR departments, where this invention report is analyzed and especially analyzed from the patentability perspective, whether the invention is novel and inventive in light of the prior art that is available for you, and also analyzing and collecting information from the technical experts in the company to review the technical merits of the invention, whether this invention is worth of patenting. So once all of this information is in place, so we can make a decision whether to file a patent application or not. And once it's decided to get the patent filed, so then it's sent for a patent attorney for drafting a patent application. And even that takes several iterations to kind of translate the technical language into the legal language. So it requires also iterations between the patent attorney and the inventor to come up with a conclusion how to protect the scope of the invention. So really, it's really also typical that we protect the inventions with patents that are contributed, but that's not the only way to kind of form your patent portfolio. So even much before those technical features are raised in 3GPP, so there is already research ongoing in companies. So really working on those new technical features that will be then proposed to 3GPP as study or work items, and also here a lot of patenting happens. And like I said, so also we discussed about the inventors. So it's really typical that we have either standard delegates, the research people, or even the product implementation people who are acting as inventors and submitting inventions. So that's in summary.
Great. No, I think it's good to have that picture, Thomas. Very exciting to see how that all comes together. Of course, one thing that I have kept hearing is, I don't know if it's a mystery, but some people have in mind that, you file your patents, you try to have your next contribution submission with as many of the patented invention as possible, and then push that invention to the standards meeting and try to get it approved and accepted. Is that really a mystery? Is that even possible? Has that happened? Is this something you can see, or is it really more everyone is doing R&D? Of course, you secure your inventions, and then by chance, some of that ends up in the standard, but others don't. But the standard setting negotiations would never consider something to be protected of IP.
Yeah, so it's also pretty clear that companies who are investing into 3GPP standardization and also are developing products in this space, so definitely want to also protect that those technical contributions that they submit to 3GPP, which are also having this meeting those patentability requirements are captured into the patents. And so there is nothing mystery around that. So I think every company behaves in this way. But then to the question of how the companies are pushing their inventions or contributions into the standard. So whether we talk about that we are pushing the patents into the standards, or whether we are pushing our best solutions into the standards. So I think you can either use either analogy. So eventually what we want to achieve as a result of the standard is to have a functional high performing standard which is supporting different use cases and product implementations, so that which the users can benefit from. So that's the starting point. But obviously there is a lot of patenting also on this space in order to secure that you have own your share of those investments that you are putting into the standardization.
That makes sense. Thank you for elaborating on this. And I want to also open up maybe even to the whole panel some more insights, and maybe you, Lorenzo, we haven't heard from you. Any comments to what Thomas said, any additional things to mention here about the relation of filing patents and contributing at the standards meetings?
I think it's fair to assume that everybody presumes that people that contribute technology, they have patented their technology if it was possible. And everybody assumes that, and generally actually never in 3GPP meetings, people don't discuss patents at all. It's not part of the discussion, it's not part of the culture. And 3GPP is really an engineering-driven organization, so it doesn't go into these legal aspects at all. It is just assumed, I think, like in any multi-party engineering discussion that would happen even outside of standards, that if two companies are talking to each other on some sort of joint technology, they presume that if they've done some certain R&D, they have filed patents on their R&D before discussing with another party. That would be common practice for any engineering company in any domain, and it's no different in 3GPP. So really what happens in 3GPP, people have like to put it, they have a technology vision. There is a certain problem to solve. They have a certain vision on how to solve it. This vision is declined into a number of small solutions that are aggregated, solve that problem. And those solutions are the result of some R&D that was done at home and which was protected by patents. And then standards delegates are going to present all those pieces one by one, depending on the dynamics of the meetings, depending on the working groups, depending on the scope, etc. And every individual piece of the solution will be discussed on its technical merit, not really because there is a patent or not. Everybody assumes that if any company proposes something, there must be some patent. And that kind of creates a level playing field. So at the end, the discussion is only about the technical benefit. Which of course it's technical benefit on different angles. People can have different perception of what the technical benefit is. Can be technical benefit for end user or for an operator, for a device vendor. That of course is an engineering discussion. And then of course at the end of the road, some people will end up with some patents in the standard, but it's a byproduct of the fact that people try to bring their technology vision into the standard.
Thank you. Thanks for these insights. And there also are already some questions from the audience because, of course, IPR is, I guess, many of the audiences here have an IPR background. And some of the questions I think were answered, but I still want to read them. So one question concerns, is there really a mapping done of which contributions cover IPR and which do not? And if so, does that matter? Diana, you're nodding that. No, that's not done, right?
Well, no, in the standards meeting, this is not done. Like Lorenzo said, the standards delegates are there, first of all, to be good engineers. Of course, before companies have done research, they file patents, but when it comes to the actual standards meeting, all of that is put aside. And what's important is the good of 3GPP. And hopefully this is how all delegates act during the 3GPP meetings.
Because here it says on the very first day, always the chairman asks for any IPR and declaration of those. I mean, I can tell you from our database that declarations, I mean, even though they come earlier and earlier these days, are not coming that early because I think many of those patents are not even published because just submitted. And we have 1.5 years time before they're really published, right? So that call is really an independent process, I guess, of declaring IPRs at, for example, 3GPP had that ETSI IP, or has that ETSI IPR database. So that there's really no connection to the standardization group then, or work.
Well, like you said, Tim, I think, of course, the chair presents this call for IPR, but it's actually a reminder to companies that this is a process that needs to be followed by 3GPP members. But how it's done, it's typically a different entity or a different group of people that ensure that patents are declared to ETSI. But at the standards meeting itself, delegates do not know what's been declared and why and how.
In my understanding, our perception is that it's done quite diligently by the vast majority of companies, or actually almost all of the major contributing companies. In fact, I read the question, maybe it's actually the question online is very interesting because it reflects maybe a misunderstanding. In reality, almost all, it's always difficult to make a definitive statement of all, but almost all applicable IPR is declared ahead of the standards discussions. And it's just not declared ahead of the physical meeting. It's just a different process because there's going to be some employee of the company that is going to send some email to some administrative person to Etsy to add those IPRs in the database, but it always happens before the meeting. Of course, there are very large numbers of IPR that get continually disclosed. It's not about one or two, it's usually dozens or even hundreds, or if not more. And then, as I said, it kind of creates a level playing field. Nobody goes into a meeting having downloaded all that information from the database and trying to parse it in real time. It's just not humanly impossible to do that in real time.
Even for machines, difficult, I can tell you. Also, to understand, patents are declared to technical specifications. We're talking about contributions here, which are, coming before the specification is even finalized. So there is no link to a contribution also in the declaration database, just for the audience to understand that. And I think also it is fair to say that you should only declare a patent when it's potentially essential, and that you only know when there's at least some final standards technical specification document that you can then map, or claim chart or claim map it to it. So I think that is also fair to say. Timing wise, it's often even impossible. But to come to data, and I think what is great about the 3GPP, I said that in the beginning, very transparent. I can really track which single person goes to which meeting, if that person was a named author on a contribution, if that contribution came from which companies, typically not one company, we discussed that. Then there are just different types, change requests, all of that. So there has been in the media some looks at those rankings, especially when we ranked companies, right? How many contributions did a company submit, let's say, to 5G, and that were, I would say, misinterpreted maybe as if these were to be compared with actual patents that are essential to that standard, or that could be a proxy for that. And I think, Lorenzo, you did quite some substantial work and analysis on this, or even contributed to some of the licensing negotiations there about that data. So how can that data actually be looked at? How can it be used? What are the limitations? What are the pitfalls when interpreting rankings? Can you elaborate on that if someone would want to look at the broader picture of 3GPP and compare which company is involved where?
Yeah, of course, and thank you, Tim, for pointing people to a couple of blogs that I've written that people can look on Google by checking my name. But I think summarizing the fundamental point on my view on this is that you should distinguish, looking at this data, between activity and value. So looking at the 3GPP data is useful to measure activity, and of course we do that. And you can get a lot of interesting information. For example, just to make some examples, cellular in the last 10, 15 years, cellular technology has become very, very successful. And the success has meant that new industries have adopted cellular technology. So now, of course, trivially speaking, you have cars that are connected with 4G or 5G, and you have scooters and all sorts of gadgets that are connected with 4G and 5G. But even more so, there are new segments that are interested in cellular technology for the future. Think of broadcasting, satellite, drones, railways. And sometimes there is a question on whether those new segments participate or don't participate in standardization. And of course, looking at the data, thanks to the fact that 3GPP is very transparent, you can get a very clear picture of who is participating, who is providing the majority of the input in a quantitative manner, who is attending every meeting and who is attending only some meetings, who is always there and who is there sometimes. And you can do the same with geographic distribution. Of course, 3GPP and cellular technology has also been a success story in terms of creating a global standard. There's a big history of 3GPP that started from GSM, which used to be a regional standard and eventually has become a global standard. So of course, you can also look at the data to measure activity from a geographical point of view, which again is going to give you some data to further the point or to see, with the numbers, certain things that you will know intuitively maybe. And that is that Chinese companies have become more active because, of course, so cellular technology have become very important in China. And then later on, Indian companies have become more active because cellular technology have become more active in India. And in the same way that if you are looking at the data in the past, at some point you would see Japanese companies or Korean companies. So this is all kind of very normal. There are certain intuitive things in terms of activities, whether in geography or in sectors, that you can back up with data thanks to the fact that 3GPP is transparent. Where we think there are the pitfalls is that where from activity you jump to value, because 3GPP is very open and is contribution driven, is very inclusive. There is nobody puts a gate about what anybody can contribute. Just looking at the sheer amount of data doesn't immediately translate into a measure of value. So that has been, of course, a very easy pitfall in the maybe media, sometimes even in the mainstream media, trying to extrapolate from these massive numbers of activity in standardization a narrative of value or a narrative of domination that does not have roots in reality. So that is, to conclude, that is really where I see the main thing. The data is very useful to measure activity in our view, and less so to measure value.
Right. Yeah, I mean, I would also comment on that, because we have, of course, many users of the data that we, give access to at IPlytics, and we do see that many find it useful. But I mean, of course, we cannot look into how they use it, and if they use it, for example, in SEP licensing negotiation, which would be an extreme case, because of course these are not patents, or if they rather use it as, monitoring, activity, as you call it, from different organizations. I think also prior art search is one use case. But of course, I think also because there was so much interest in the past years in participating and contributing at the 3GPP, there has been even some, some changes in the procedures. Maybe Janne, you can comment on that, because I also see that the total number of contributions is not straight increasing as I would expect it, because technology becomes more complex. 5G is a bigger project, maybe as 4G, but there is a wave in there. And maybe you can comment on this, and maybe also give your perspective on looking at the data of the 3GPP, which I know that Ericsson also has that database internally, and you look at that sometimes as well.
Yes, so I think it's a very good observation. I think what we saw at the beginning of 5G was that 3GPP became very successful. There was a lot of interest in providing contributions. And maybe the 3GPP ways of working, it was too open, too unrestricted, too unstructured. And that led into a flood of contributions where many of the contributions were simply submitted from one meeting to another because they were not able to be treated in upcoming meetings. So that was creating a problem in 3GPP. The number of contributions was flooding. There was no efficient way of dealing with that. And for that reason, selected groups in 3GPP, primarily overall groups, run 1, run 2, later run 4 as well, they actually introduced a cap of contributions. So in one particular agenda item, one company can only submit one contribution. And that has pros and cons, but I have to say it worked very well in solving this 3GPP procedural issue. There is less contributions, there is more time to actually go through a higher percentage of contributions. And that has then led to a situation where we don't have a linear or even worst case exponential increase in number of contributions that are simply resubmitted from one meeting to another. So I think that was very, very good solution in the end from efficiency of 3GPP point of view to solve this sort of being a victim of its own success. Then on this sort of use of data, I of course agree with Lorenzo that data is very useful. And as Lorenzo mentioned, the basic assumption in 3GPP is that whenever there is a technical contribution that has some technical value, the basic assumption that companies are making is that most likely the company will have IPR on this. So I would expect that there is a correlation between the number of contributions submitted or approved and the number of essential patents held by the company, simply because that is the mode of operation for many companies. And while I agree with Lorenzo that the number of patents is maybe not the best possible indication of the value of the patent portfolio, I would still claim that most likely there is a fairly large correlation between the number of patents that you have and the overall value of your patent portfolio. So I think there is clearly a correlation between the 3GPP data and the patents owned by the company, but of course it's not one-to-one mapping, and it's definitely not one-to-one mapping from the contribution to value, as I would say.
Yeah, that sounds good. Maybe also one follow-up question on this to you, Lorenzo, because I know we have been cooperating with you a lot also on how to read data, and a contribution can be approved or accepted and then approved, and a contribution can be technical and non-technical. And actually, you can identify at least the technical ones. There are categories, and for example, I think it's category B, it's an additional feature, is maybe an indicator for a technical contribution compared to I think a category D, which is an editorial modification. I guess that is probably typically not technical. And there's also the statuses that is very transparently there. But even there are some limitations to look at that data. And just to give some background, it doesn't have to be so specific, but how does this 3GPP work? How consistent is it? How can you use those categories or statuses and kinds to give or provide more sense to it?
Yeah, I'll try to give a kind of simplified answer because there is a lot of very specific nomenclature. But let's make an example. Let's say that the five of us decide that we want to go to a weekend trip, and we will carpool, and we are going to discuss where to go, and everybody's going to discuss going to propose a different destination. And eventually, through some pros and cons, we will settle on a destination. And then there's going to be somebody that drives the car. And not necessarily the person that drives the car is the person that has proposed the destination where we're going to. So this is a very, this is very important distinction. So in this example, you could imagine by looking superficially that the person that is driving the car is the one that has decided that we're going to go to the mountains for hiking. But maybe it's not like that. Only by knowing what we discussed earlier on, you could find out that maybe I am driving and Janne proposed to go to the mountains. And then for whatever reason, I am driving just because maybe I'm more comfortable driving or I have a better car. But the original idea of going to the mountains comes from Janne. So this is why this example, I think everybody can understand why there is the analogy in 3GPP. In 3GPP, there are almost 2 layers of activity. There is the actual, like Janne said earlier, there is actually technology that is most generally put forward through discussion documents where technology's ideas are discussed and the engineering is explained. And then there are the formal documents that propose the actual changes into the standard, and are this category B or D or A or C that you cited. And there is no direct mapping. The mapping often is broken between those that have proposed technology ideas and the contributions that mechanically add them to the standard. And the reason why that linkage is broken is simply due to the working culture of 3GPP. There is no particular mystery. Maybe 20 years ago, 25 years ago, that linkage was not broken. The organization was much smaller. But with the organization growing, there are certain set of subcultures and working cultures that have emerged, where eventually there are some people that are very skilled at writing changes to the specifications. And they do that, which is of course very valuable for the overall industry. And they do that carrying forward also ideas that have been proposed by others and accepted by the community. So this is why also looking at these different categories of documents that are also cited in the specialized press, sometimes a category A, B, C, and D, again, is useful to measure activity from a certain point of view, but it's not the whole story. And it's not the whole story for the same reason of the earlier analogy I made of carpooling in the car.
No, that makes A lot of sense. Thanks for that analogy, Lorenzo. And I think it's similar with patent counting. Of course, one patent invention can be changing the world. The other one is just a small merit of a small thing that changes something. But I think in data, of course, you have to always think about the rule of large numbers and get some correlation in, as Janne said. But I leave it to everyone using data to interpret it. But I think we had a great panel today that gave some insights. There were some more questions here that I would then share with our panel speakers here, the experts, to answer them after this session. But I want to be mindful of the time. And also, what I typically want at the very end is a final statement, just to summarize and basically give an understanding of what we heard and what we learned today. So I would like to go around the horn again and have every one of you guys, of the experts here today, give your 2-3 sentences of what the people should remember from this webinar. Maybe I'll start with you, Thomas.
Okay, Tim. So thanks. So first of all, I would like to want to thank for organizing this this webinar, and what people would be good to remember from this is, first of all, to understand that what is the basic process of 3GPP standardization. It's really a complex involving multiple companies, and also to get the view on how the patenting process works, so that the companies who are participating in the standardization are bringing their best ideas into the table, and typically those proposals are also protected by the patents. So and that's really a common practice here. And maybe also to also comment on this pattern about this contribution counting. So I also tend to agree what Janne was describing, that there must be some correlation between the 3GPP activity, and especially when we look at the quality of the contributions. So one potential indicator here is the approved contributions. So contributions which are kind of found to be worth of taking forward in the standardization process. But maybe just to leave others also time to continue. So my 2 cents.
Thank you for your final statement. Lorenzo, you want to give yours?
Yeah, thank you. Well, thank you, of course, for organizing the webinar. I hope it was educational for the public. Well, I conclude saying 3GPP is a very large organization, very successful. It's a tremendous story of success of standardization for cellular technology, and in doing that, it has a great history of being inclusive and being based on a very special mix of collaboration and competition, which is kind of unique. And because of this, we also see that there are some of the most important working groups in 3GPP have a very specific working culture that has emerged bottom up. And also that is somewhat unique in the overall standardization ecosystem. So once you put all of these things together, that they create a little bit of the magic of 3GPP and probably reasons for its success. The other consequence is that we have to be careful in just looking at the raw data coming from standardization documentation to make big conclusions, because in reality, what we always have to remember that we have to filter this raw data through an understanding of how the processes really work. And that is, to me, is the main takeaway of this whole discussion.
Great, thank you, Lorenzo. Diana.
All right, well, thanks, Tim, once again for organizing this webinar. I think maybe one thing to touch upon, because I don't have a chance to speak about the data, I do tend to agree with Lorenzo that, of course, data can be very useful in general to see and identify who's participating, who's the new market entrants, the history of participation of a company. But we need to be very careful when we take those numbers on their own to analyze and understand technology, leadership, or influence of a company, because I think contributions, first of all, are not created equally. as a chair of 5G, actually, at the beginning, I can tell you that quantity does not necessarily correspond to quality either. So I think there's a lot of intricacies in 3GPP. It's very complex. So just analyzing raw data is typically also not the best proxy for analyzing leadership. And then, of course, the taking approved CRs or approved documents as a proxy too is also not the best approach, as Lorenzo explained, and it's ignoring 18 months of discussions between companies, because as I explained, it's based on consensus and thousands of agreements that were made for 15 months captured in a single CR, right? So we have to remember all of this together. And I think the last thing that I did want to say is, I think we all know innovation is key to the future of the technology. And of course, we know that companies do protect their ideas because it's an important part of their investments in research and development. But when it comes to 3GPP, I think companies will contribute with what is best for the technology. And I think that's the #1 priority for companies, of course, including InterDigital, is that 3GPP advances in the best way possible. And if you do great innovations, ultimately, I think the consensus building process will include part of your inventions based on the technical merits anyways.
Great. Thank you for these final words, Diana. Janne, last but not least.
Yes, I would like to really chime in on the learnings from all the 3 previous speakers. I think 3GPP is a very successful organization. I think it's amazing on how it has grown and how it has been able to produce specifications for mobile generations from 3G to 4G to 5G, and hopefully soon for 6G. And I think the way to do that, how do you really bring together hundreds of companies and thousands of individuals? It really relies on the 3GPP culture, like Lorenzo was mentioning. It is a culture that is really enabling collaboration. All decisions are taken by consensus. There is no need to vote because topics are discussed to death. And like Diana said, the main argument in 3GPP for choosing a technical solution is always the technical merits. So you get the chance to present as many times as you want the merits of your company. And if the merits are good enough to convince other companies, you will get support. So it is kind of a very much an organization based on the technical merits. And part of the reason why 3GPP culture is so successful is that it is open, inclusive culture. So everyone can come in, everyone can see the discussions. And this openness is then maybe the reason why we actually have a possibility of getting some data into 3GPP. I don't think we need to discuss a lot of how valuable data is. I think it's just amazing that we have a possibility of looking at what has been the share of the contributions from Indian companies since 2011. It's not that many organizations where we can do this kind of analysis.
Yeah, and I have to agree on this. Openness is great also for data companies, especially since patents have that 18 months of delay, and contributions, once protected, they are typically very promptly presented and then available. So that delay is also with contributions in the particular areas of cellular technology not really there. We see in inventions more early on. I think that was a great panel. Thank you all for your insights. We had real experts here today. Feel free to send us questions if you have still open questions, but I think many of the questions were answered today. This webinar was also recorded, so if you think your colleagues should also see it and learn, share that. We will share the recording with all of you afterwards. I'm left to say thank you everyone for contributing here. Thanks for coming today. Thanks for your time, and I hope to see you next time. Take care. Bye-bye.
Thank you. Bye.